Okay, hello everyone. My name is Matteo Benussi, and today I will present you my master thesis work, and we will talk about green LED light implementation in Northern Adriatic Sea and their impact on the target species catch in static fishing nets. So Northern Adriatic Sea is used by set net fisheries operating with static fishing nets. You can see that on the left picture, and the same area, as Tinkara said, we have sea turtles in Northern Adriatic, but that area is one of the most important foraging area for turtles in Mediterranean, and their overlapping leads towards incidental interactions of sea turtles with static fishing nets. Number of bycatch on Adriatic and Mediterranean scale is alarming, but what is more devastating is mortality rate, which is between 60 to 80%. And because of that, static fishing nets are one of the most lethal fishing gear for sea turtles used by the fishermen. The reason of high mortality is caused by long duration of net soaking. So when fishermen throw a net or set a net, it can stay under the water for 8, 12 to 24 hours. So that's not a good reason for sea turtle. Okay, and in fisheries, we are faced with that problem, like in Peru and Mexico. They tested possible solution by implementing the green LED lights on static fishing nets. Now, green LED light works that they illuminate the net, and turtles that rely heavily on visual cues can see the net and can swim away and not get entangled in the net. So this practice showed reduction in turtle bycatch from 40 to 74% and no significant effect on target species catch. And that's important, you'll see, because firstly, now, during 2018-2019, green LED light was implemented in Northern Adriatic as turtle bycatch mitigation measure. And one of the factors important for acceptance and implementation of green LED lights was to maintain target catch and value. And this was my master thesis about. And the main aim of that was to evaluate effect of net illumination on target species catch and value from the typical static nets used in Northern Adriatic, which are thermal net and gill net. Now, the main difference between them is layering. Thermal net have 3 layers, gill net have 1 layer. The mesh size, the mesh size, which is on thermal net have smaller mesh size and the gill net have bigger mesh size, height, and of course targeted species. In thermal net, with thermal net, a common sole is targeted mainly, and with smoothhound, with gill net, smoothhound is the main targeted species. But additionally, in that nets can be catched non-targeted but commercially retained species like lobster, brill, scorpion fishes, and so on. And now experiment trials are conducted under the real fishing conditions. You can see the boat, typical boat equipped with thermal net and gill net. And fishermen departed from ports of Umag and Savudija in Croatia and from ports of Piran in Slovenia. And this is the area and the ports where we conducted the trials. Now, this is how this green LED light looks and what model we used. And the operating model, like I said, when green LED light get in contact with the water, she lights up. Now, the green LED light was placed approximately 10 meter 10 meter interval, on the bottom rope of the net, which is heavier than the upper one, which is lighter. And this is how it looks. Installed green red light on the bottom rope of the net. Now, this is how it looks set up. Now every net equipped with LEDs have a referent net or control net. And this is how it looks controlled without any LED lights and experimental with 10-meter interval LED light placement. Now, data is collected by onboard observers. And we, as onboard observers, really experienced that fishing practices by waking up at 3 o'clock in the morning, and depart with the fishermen to get to the location where net is setted or thrown. After that, net was pulled out and data was recorded from that net. And after that, catch was entangled out of the net and was measured, weighted, and sorted into 3 categories: retained commercial, retained other, and discarded bycatch. After that, when fishermen cleaned the net, they throw or set the net again, and we again recorded all the data from the net. And here we can see how it looks, that net throwing on the fisherman boat. Now, after that, data are analyzed, and for each net was calculated catch per unit effort and price per unit effort. So like all the weighted fish, all the prices, net length and net soak time was calculated inside of this formula. And values of experimental and control nets are compared with Wilson matched pairs Sangrach test. And this is results. Now you can see all the nets where they are set. The green one is control and experimental are the green one is experimental, a gray one are control. And this is the result. So data from 161 pair of set of tramolets is collected, and 98 sets of gillnets is collected. And inside of this table, we can see that with approximately the same total fishing effort, it is reduced targeted species in trammel net, like in kilograms. While in gillnet, there is no any impact. And this is the box plot that shows catch per unit effort, the price per unit effort for control and experimental net in gillnets, with no significant effect on the targeted catch. And in trammel nets, we can see also that, but with significant reduction in illuminated net, which is 23% in catch per unit effort and 27% in price per unit effort. Now, for conclusion, these results show an impact of green red light on target species catch in tramolets, while on the gillnet there are no effect. And that's highlighted important. These results highlighted the importance of estimating effects of conservational measurements. Another conclusion, like general conclusion, I can also highlight that collaboration with the fishermen is essential for further studies of fishermen's impact on the marine environment. And we can collect data only by the onboard observers, no matter what the difficulty is that job to be onboard observers. But with that collected data, we can create really quality science-based conservation. Thank you very much, and this is all for me.